So hello, today we are going to discuss group 15 and group 16 of Pblock elements class 12th, what only the portions that are needed for the Neet exam. Okay, that is the general characteristics. So first we are going to learn about group 15. The members of the group 15 is nitrogen and phosphorus. So the first two members, if you are considering nitrogen and phosphorus, they are non-metals. I am representing it as Nm. Then the next two members, that is the nitrogen phosphorus, arsenic and antimony. They are metalloids. I'm representing it as metallo. I don't have space to write. Then bismuth and moscovium, those are metals. Okay. So moscovium is a man-made metal, it is radioactive. Then the next one is this group 15 is also known as pricogens. Now we are going to learn about its occurrence. So okay, so first what we have to discuss here about occurrence is the first member, that the nitrogen, it is present as N2 gas, which is 78% of the atmosphere as N2. Then in Earth's crust, it is present as Indian saltpeter. The Indian saltpeter is nothing but KNO3. And the child saltpeter, that is the NaNO3. It will be very comfortable for you guys if you open your Ncert textbook, because I am teaching in its order itself. Okay. So KNO3 is the Indian saltpeter and NaNO3 is the child saltpeter. This is all about the existence of nitrogen. Then we have phosphorus. It is mainly present in bones. Then apart from it, it is present as minerals, which is present in the apatite family. Minerals belonging to the apatite family is also present here. And the general configuration of the minerals in the apatite family is Ca9, PO4 6 times dot CaX2, where this X can be OH or F or chlorine. F means fluorine or chlorine. If it is fluorine, then it forms fluorapatite. Okay. Then phosphorus, that is only about phosphorus. Phosphorus is also present in phosphorus. Okay. That is also very important. Then the next is the existence of arsenic, antimony and bismuth. So arsenic, antimony and bismuth. So here they are present as sulfide minerals, not sulfate minerals. It is important. They are present as what? Sulfide minerals. Okay, that is all about their occurrence. The next characteristics that we have to learn is its electronic configuration. Its electronic configuration, which I am representing as EC. Its general electronic configuration is Ns2Np3. We can say that it is halfly filled. It is an extra stable configuration. Then the next characteristics that we have to learn here is its atomic and ionic radii. Atomic and ionic radii. Okay. So the atomic and ionic radii. So one thing that is important about atomic and ionic radii is generally we can see that down the group the size increases because the new shells gets added. So from the table, if you observe, the order of the covalent covalent radius. I'm writing the order of covalent radius, which I'm representing as Cr. The order of covalent radius is nitrogen greater than, less than phosphorus, greater than nitrogen, phosphorus, arsenic, antimony, and bismuth. This is its covalent radii order. But if we can see that from nitrogen to phosphorus we can see a considerable increase, but in heavier members we cannot see that much considerable increase because of the adding of the bigger subshells like D and F. Okay, now when we are considering the ionic radii order, then it will become Sb, Bi, then nitrogen, phosphorus, arsenic. Okay, so these orders from the text, from the tables, is also very important. Okay, this is the ionic, this is the covalent radii, and this is the ionic radii. Here it is, we can see a variation in the ionic radii, which you all guys have to note. Okay, the next characteristics that we have to learn is the ionization enthalpy, which I am representing as IE. So we can say that as we go down the group, we can say there is an increase in there is a decrease in the ionization enthalpy because the nuclear attraction to the valence shell decreases as the size increases. Okay, so the order we can say that this grade of nitrogen, then phosphorus, then arsenic, then antimony, then bismuth. Okay, this is about nitrogen, phosphorus, arsenic, antimony, and bismuth. Then we can say that the group 15, the ionization enthalpy of group 15 is greater than the group 16, or the group 14 we can say. This is because, do you know why? It is because they have extra stable halfly filled electronic configuration. So the ionization enthalpy is generally higher for all of them. Okay, then the order is this. Then for the successive ionization enthalpy we can see an order of, for the first ionization enthalpy is greater than the second ionization enthalpy, it is the third ionization enthalpy. I hope you guys have understood. The next what we are going to learn about is its electronegativity, which I am representing as En. So electronegativity, we can say that they are electronegative, but towards the electronegativity decreases. We know that as size increases, electronegativity decreases, but among the heavier members, electronegativity difference is not that much pronounced. That is, if you observe the table, we can say that their order is nitrogen, phosphorus, arsenic, antimony, and bismuth is almost the same. This is what they're talking about. Okay, is not that much pronounced, and the reason for it is not given inside the Ncert, so you guys don't have to worry about it. Next, what we have to learn is about its physical properties. Okay, these are all short forms. Okay, so what are the physical properties that we have? Here we can say that all the members are polyatomic. Then we can say that the nitrogen is the only gas formed here. It is a gas, while rest of the members are solids. And also we can say that the metallic character increases as we go down the group. The metallic, I'm already writing metallic here. Metallic character increases as one goes down the group. Okay, next is, this is because of the increase in the size and decrease in the ionization enthalpy. Next important thing is its melting point and boiling point. Its melting point is nitrogen and melting point. Its melting point is nitrogen, phosphorus, bismuth, antimony, arsenic. Then in boiling point we can write nitrogen, phosphorus, arsenic, bismuth, okay, bismuth and antimony. Okay, so these are its order. Then one important thing that we have that is given inside the NCERT is all elements except nitrogen forms allotrope or show allotropy. That is, nitrogen does not forms allotrope. Okay, I hope you guys have understood. The next thing what we have to learn about it is its physical property is its density. So density, it increases down the group. As one goes down the group, its density also increases. Okay, its density also increases. As one go down the group, density increases. Okay, its density increases. These all are about its physical properties. I hope you guys have understood. The next what we are going to learn is its chemical properties. Chemical properties. Chemical properties. So in chemical properties, what we have to learn is its common oxidation states. So here the common oxidation states are okay guys, you can forward the video. Sorry for the interruption. Okay, so chemical properties. So the chemical properties that we have to learn here is the first one is the common oxidation state. So the common oxidation state, it includes -3 plus 3 then plus 5. Okay, then as one goes down the group, what we can say that as one goes down the group, the stability of -3 will decrease, stability of plus 5 will decrease, the stability of -3, the plus 3 will become increasing. And do you know what is the reason for this? It is the inert pair effect. Inert pair effect, I am writing it as E. This is the inert pair effect. Then we can say that nitrogen apart from all these common oxidation state, nitrogen exhibits +1, +2, +4 oxidation state. It won't exhibit +5 like any other members because it is the smallest and it does not have the d orbital. So nitrogen also it shows nitrogen always when its oxidation state from +1 to +4, it disproportionates in acidic solution. That is very important. It disproportionates in acidic solution. That is important. So then the next one is that we have to learn here is about its okay. So first thing that we have to learn here is about its acidic solution and all those. Okay, so next we are going to talk about is phosphorus. So in the case of phosphorus, it shows +3 and +5 oxidation state. Phosphorus undergoes disproportionation in both acidic as well as alkaline medium. In both acidic as well as alkaline medium. Okay, so due to disproportionation, the +3 oxidation state is highly stable in elements like, which are elements? Tin and antimony and bismuth. +3 oxidation state is very highly stable. The maximum covalency of nitrogen is limited to 4. Absence of d orbital is the reason for it. Now, because of the absence of d orbital, nitrogen also shows anomalous properties. So next what we are going to learn is about the anomalous properties of nitrogen. Excuse my handwriting. So what we are going to learn is about the anomalous properties of nitrogen. Nitrogen cannot form p-pi bonds. Nitrogen cannot form p-pi bonds. No, sorry. Nitrogen forms p-pi bonds. It cannot form d-pi bonds. Rest of the members, due to the presence of d orbital, it forms d-pi bond. But it cannot form p-pi bond. That is because the rest of the members can't form p-pi bond because of their large size. Okay. Then important thing that we have to learn is rest all the members when they are in the molecular form, they exist as diatomic molecule, whereas nitrogen also exists as diatomic molecule, but that too with a triple bond. That is the difference. Then if you're considering the strength of the single bond of the nitrogen with the single bond of the phosphorus, we can say that surprisingly the single bond of the phosphorus is having more strength. The reason for this is the nitrogen have lone pairs, so the repulsion from the lone pairs is also expected, and also due to the small size of the nitrogen, the bond length is so small, so the strength of the repulsion, it increases the strength of repulsion. Another important point that we have to understand is bismuth. Bismuth it exists as in the form of metallic bonds in both elemental state. Okay. Now one important thing is that I told you that nitrogen only forms p-pi bonds, whereas in all other members forms p-pi d-pi p. So we can say that the phosphorus, in this case we can say that the arsenic and phosphorus have the special ability, the arsenic and phosphorus have a special ability to form d-pi bonds. Okay, that is also very important. Then the next thing is about its reactivity with each of the important reactive elements. Okay, so we have discussed a lot in this video. I hope you guys have understood. If you didn't understand, you can mention that in the comments. I'm available at any time. Okay, even if you guys need my assistance, I can give you my WhatsApp number so that I will help you out. Okay, so the next is okay. So even if you didn't understand any part, feel free to ask. Next is, because I enjoy children asking me doubts. Okay, so I hope you guys are understanding what I'm teaching you right now. Okay, so next is the reactivity with which element? With hydrogen. With hydrogen. Okay, so what we can say that it forms elements of the form it forms element of the form EH3. Okay, so this next is the stability decreases. Stability also decreases as we go down the group. So from the decrease in stability, we can understand that the bond dissociation enthalpy will also decrease as one go down the group. So the order of the bond dissociation enthalpy for the hydride is, it will be greater for NH3, then decreases as we go down the group. Okay. Then the next important thing that we have to learn is about its reducing character. So as one goes down the group, the reducing character also increases. That is, we can say that the ammonia is a mild reducing agent, whereas BiH3, it is a very strong reducing agent. Okay, then the next important thing is ammonia. It have very strong hydrogen bonding. So because of this, ammonia will be having a relatively higher boiling point and melting point. So the order of the boiling point and the melting point are, so for the order of the melting point is, okay, then the boiling point okay. The next what we are going to learn about is its reactivity with oxygen. Okay, its reactivity with oxygen. It forms oxides of the form, and okay, so as it goes down, the acidic character of the oxides also increases. Okay, the acidic character of the oxide, the acidic character of the oxides decreases as we go down the group. The acidic character decreases. Then important thing that we have to learn here is, if we are considering the oxide of the form E2O3, if it is in nitrogen and phosphorus, then it forms acidic. Then in arsenic and antimony it is amphoteric. Then for bismuth it is basic, because these two are, in the starting I've told you that they are non-metals. Then these are metalloids and these are metals. Okay, the next thing that we are going to learn is about the reactivity with halogen. Reactivity with halogen. So in the case of the reactivity with halogen, it forms the halides of the form EX3 and EX5, and nitrogen does not form EX5 form. This form is not formed by nitrogen because of the absence of Pblock element, and we can say that the EX5 is more stabler than EX3 because they are more covalent than EX5s are more covalent than EX3 because the polarizing power for an element with oxidation state +5 is more than the polarizing power of an element with oxidation state +3. Then all of them forms trihalides except NH3. Okay, we can actually see that the NX3 forms. NX3 are especially unstable, but an exception to this is the presence of NF3, so it is stable. Then all the ALX3 compounds are covalent. All the ALX3 are all the EX3 form elements are covalent. They are covalent except which form? Except the BIF3. All of them are covalent. Okay. Next important thing that we have to learn is its reactivity with metals. Is its reactivity with what? Is its reactivity with metals. Reactivity with metals. So it forms very important thing, it shows +3 oxidation state when it is reacting with metals. Some of the compounds are given inside the textbook. So this is all that we have to learn for the coming NEET exam from the group 15. In the next video I will be uploading about group 16, and now we can just revise what all we learned in this lecture. So this was a long lecture, isn't it? You can see how long it was. You can see, right? So long. So let's start from the beginning. I just thought that I can divide the group, every group into different columns and all. So first we learned about, okay, first what did we learn about? First, okay, so first we learned about it. Okay, so first we learned about that the nitrogen and phosphorus are non-metals. Then we can say that arsenic they are metalloids. Then bismuth and moscovium are metals. But this one is what? This is a man-made metal. It is radioactive. It is also known as pricogens. Then we learned about its occurrences and its occurrence. Then electronic configuration, it is having extra stable electronic configuration, atomic and ionic radii. Covalent radii is like we expect, but there is a variation in ionic radii. Ionization enthalpy, nothing to learn, nothing to by heart, because it is as we know. Then in electron negativity, we have to know that the Sb and Bi is having almost same electron negativity. In physical property, nitrogen is only gas. Then metallic property decreases as increases down the group, that we know, right? Then the melting point and boiling point order, it is very important. It does not show allotropy. It is very, very, very important. Okay, very, very important. Then what we have is the density. Density order is also density increases down the group. Okay. Next we learned about the chemical property. In chemical property we learned about its common oxidation states. Then we learned that due to the inert pair effect, the stability of the each oxidation state. Then we learned that the oxygen shows +1 +2 and +4, with nitrogen shows +1 +2 and +4 with oxygen, and from that it is acidic in solution, then +3 and +4, then Sb and Bi is especially stable in +3 because of disproportionation. This is very, very important. Maximum covalency of nitrogen is 4 because of its small size. And because of all these exceptions, nitrogen is showing some of the anomalous property which we separately learned. Nitrogen can form p-pi bonds. That is really, really important. Nitrogen can form p-pi bonds. Nitrogen form triple bonds, while rest of them forms the single bonds. And if you're comparing the strength of the single bond, the pp bond is more stable, stronger and stable. Then arsenic and phosphorus can form d-pi bonds. Then we learned about the reactivity, the common form, their stability, then the bond enthalpy decreases. So from this we can understand the stability also decreases down the group. It is reducing character, who is a mild reducing agent, who is a strong reducing agent, its melting point, its boiling point. Then we learned about the reactivity of oxygen. So in the reactivity of oxygen we have learned about its common the general formula. Then as we go down the group, the acidity decreases because we learned that as we go down the group, the metallic character increases. So the oxides of the metallic are basic, right? So the acidic character decreases and the basic character increases as we go down the group. Then reactivity with halogen, the we have told one important thing, that here it is the EX5 forms are more covalent than EX3. It is because of the increased polarizing power of an element with +5 oxidation state. Then NX3 is unstable, but NF3 is an exception. EX3 are covalent. Here the exception is BiF3. Then reactivity of metals, it shows +3 oxidation states. Okay, I hope you guys have understood. Thank you. Then subscribe my channel. This is my second video. I hope you guys are liking it. Please like, share and subscribe. Thank you.